How do you know if a graph has to be solid or dotted line when doing absolute value? There's a solid line, there's our dotted line. How do you know which is which? Well, remember the solid lines have the bars underneath of it, the dotted lines do not, are spotted here. Okay? So notice this problem right here, no bar. So first off, I'm going to pretend it's just an equal. Y is equal to negative 3x plus 9. M is negative 3, or meaning it's a rise over run of negative 3 over 1. The y-intercept is 9, or at 0, 9. So I'm going to put a dot at 0, 9. I'm going to go down 3 over 1, down 3 over 1 again. And this time instead of making a solid line, because there's no bar, I'm going to make it a dotted line. Now that's the positive graph line. Now I can do the negative graph line by simply, in a sense, doing this, keeping the signs the same way, add the negative y here, and then solve, just ignoring this one. So you notice this is the first part. That's our graph up there. Now I'm going to graph the negative y answer. So basically, what we have here is this. It's the same thing as dividing by negative 1. So my m is what, 3? Or I could write it that way. Y still greater makes it equal for you to solve it that way. The m is 3, or 3 over 1. The y-intercept is at negative 9. If I'm going to put a dot at negative 9, this time I'm going to go up 3 over 1, up 3 over 1. Notice, it's going to cross right there. And once again, it's a dotted line. Now, I think it's easier just to graph this line down to the y and then reflect it. It's going down 3 over 1, so now it's just going to go what? Up 3 over 1. And here's my question to you. Is the y greater than or less than? So if I'm standing right here on the y-intercept, where is y greater? Up here. So I shade right there. That's it. You got to graph, just pretend it's an equal, graph it, reflect it, and then ask yourself which is larger or which is greater.